Good morning. So I am that guy in the room that's going to do it a little differently. I was told yesterday that I'm actually not even allowed to be here today. Because, you know, Lisp is not a workbench. So I'm glad you still allow me to talk. Yeah, so I said a Lisp. There are a lot of Lisps, of course. I picked Clojure because it's hip and it's on a JVM, which gives you a lot of libraries to use. So why did I pick it, actually? Well, first of all, Lisp is like the traditional language for metaprogramming, for writing DSLs, actually. And it's made very easy because it has macros, which allow code rewriting, and it doesn't need a parser because there is basically no syntax. You write everything in as expressions, which is basically you write your AST, your code, and that's it. So you don't need a parser. I'll show an example of that in a minute. And I think also my focus is a little different than the rest of you here. I'm not a researcher. I am a practitioner. And as such, I am looking for tools that make myself more powerful. I want to do my work faster. I want to do it easier. I want to raise the level of abstraction of the work that I'm doing. And I have a very limited audience. I don't need end-user programming. I don't need to make it easy. I have an audience of one, which is me, and I want to write stuff more effectively. And the selfish reason for doing it in Clojure is I wanted to learn Lisp, so I did it. So I also have to say the code that I wrote may not be very idiomatic Lisp or Clojure, because I was learning this while I was doing it. So a little more of my solution. First of all, what I do when I want to make a DSL is I start with what I want it to look like. So this is the canonical example, and this is what it looks like in Lisp. I hope it's readable by everyone. Font is large enough. This is like an S expression. You have parentheses, and inside of those parentheses is either a word or another parenthesized sub-expression. Usually this means a function application, so the first thing will be the name of a function, and the rest will be arguments inside the parentheses. Well, in case of a macro, you can do whatever you want with it, because the macro gets past all these the literal content of this. Can you see it as well? The contents of what you pass, and then you can do whatever you want with it. Typically, you transform it into something different, into other Clojure code, which will then get compiled normally. Some brackets are round, some are square. It's more typical to do with square brackets. They are vectors, and it has better performance characteristics. You don't need to worry about that. They're mostly the same thing, round and square brackets. So, this is what the form looks like, obviously. So how do we process it? Well, we have a macro, which I said gets past this literal array. And I do pattern matching. So I just say, well, for every element, if it looks like this, if it looks like, starts with the keyword calc, then I capture, the other parts into variables, and I do something with that. This is a quote, which means everything in here is output as the result of my macro, which will then get compiled normally. And of course, I omitted some details. Actually, pattern matching is not part of the language. It is a different DSL called Clojure.core.match, which I reused for this. So very easy, I just look, well, what does it look like? And I generate some code based on that. Well, what kind of a code do I generate? This is basically what happens. So we have the form definition. If you see the diagram, it gets compiled to a function that takes a factory argument. A factory object. And I do that, and that will take care of creating the widgets. So I want to be able to reuse the QL engine, the one that says what the forms look like. And I want it to be independent of the output medium. I want to be able to make a web GUI, I want to make a swing GUI or whatever. So I separate that out, I have a factory, and I just send new widget calls to that factory from the function that I generated over there. For the implementation, I actually used, it's a swing GUI, and it used another Clojure DSL called Seesaw, which is a nice layer on top of swing. This has another nice advantage that it splits the UI generation and the QL logic out, which I'll show you later on. An interesting one is expressions, and then we're talking about reuse. My first idea was expressions. I can simply completely reuse the Clojure expression syntax. See, I have this expression, which is minus price det. For those not familiar with Lisp, this is actually price minus det because it's, you prefix, you use prefix notation for all the operations. And the only thing minus is already valid in Clojure. So the only thing I need to do is make sure that I get the value of price and det, whatever they are, at runtime. So I transform this into a function that takes an argument of a function, something that will look up the value of my object at runtime. So I transform this into this, and I'm done. Right, and this is very trivial. You recursively loop through the expression. If it looks like a variable, I translate the variable into a lookup function, or a lookup function call. And otherwise, I don't do anything, just pass it through. This comes out, gets compiled by the Clojure compiler. Done. I have translated my expression and I can now evaluate it at runtime. Of course, there was this nasty tiny detail that we had the undefined value. So that's not a valid value in Clojure right now. So I cannot do that exactly. So I have to make operators that are aware of the undefined value and do something special for them. So actually I make a table of supported operators, which is basically, I have a plus and it's just the normal plus, but lifted to also accept the undefined value. And what the lifted function does is actually, if any of its arguments is undefined, it will return undefined, and otherwise call the underlying function. And now I don't only translate the variable lookup, I also translate the operator lookup. So, tiny modification to support this, and still nicely done. I do now not have the entire Clojure expression, expression language available to me anymore. It's only these set of operators that I defined that I can use now. I told you before that the splitting out of the QL engine, let's say, which uses create widgets calls to a factory, has a nice side effect, and it does so for QLS. So this is what I want QLS to look like. I have some styles. For a type of variable, I have some attributes, some things that need to be changed. You can probably see or guess what's going on here. These things are actually, the foreground blue, for example, is just an extra argument to a seesaw, the UI library that I use, constructor call that creates widgets. So what I do is actually just pass these on, right, and I can reuse again. Yeah. The styling language for Seesaw, Seesaw to use inside QLS to see what kind of styles I can add to my my controls. And I have one separately, it's called type, which controls the constructor function. So I can style widgets, but I can also completely use a different type of widget for some type of input. So what I do, what does this generate? It actually generates a type of factory, one that wraps the original factory. So I have my my function generated from that form. I generate a wrapper for a GUI factory from dev styles, which just modifies the new widget call as it comes by. So if it's a widget of that type, right? If it has the same name, I add the, let's say, we'll make this blue to the GUI factory, and I can compose these. I can just create as many styles as I want and just chain them up and combine all these styles together like this. You could say it's a hack, but it's very effective and gets me where I want to go. I just wanted to separate out the style and the details. There is another slight hack, right? To make this work, to make the wrapper be able to know when it needs to change the style, I need to pass in the name of the widget that's going to be created. And the GUI factory actually shouldn't need to know that, right? It just needs to create a text box, doesn't need to know what the name of the text box is going to be. To make this work, I had to add that. So now it passes on the name, and at the end, the name gets thrown away. It's just for the intermediate. But small modification and it works. Another aspect of the solution was validation. Again, this is entirely do-it-yourself, right? I have an entire syntax tree. I can inspect it at compile time, and I can do whatever I want with it. So I can run checks on it. Currently, I have implemented, expression translations are checked for valid variables, and I have checks for circular dependencies. All the rest didn't get around to implementing it. A slight downside is that errors happen at compile time. Right? They're not live as such. They're triggered when the Clojure compiler runs my code, runs my macros, and the macro throws an error, and then there's an error and you have to do it again. For me, that's okay. And I was designing for myself. So I'm getting to conclusions. Clojure, well, the good. It's trivial to make DSLs in this. I can just take a piece of code that I wrote and make it behave differently at compile time. I can use pattern matching to do it, but it makes it very, very convenient to write exactly in an understandable way what I want it to happen. And reuse is trivial. I just rewrite or reuse parts of other DSLs. And ultimately, you know, all macro expansion happens in this library or that, I don't care. And ultimately, the code gets compiled by the compiler, and what I want happens. Already use CISO and core.match. You can use whatever. There are libraries for infix parsers if you don't like the expression syntax or whatever. And my solution is small. It's 400 lines of code, which I also find a great advantage. Of course, not everything is good. There's also a bad. Is dynamically typed? Not that great, and there is no tool support, of course. See, I program in Vim, and I run my compiler or my REPL, and that's good enough for me. May not be good enough for end users, although, you know, if the candy is good, let's say, if the reward is good, they'll go to lengths to use it, I expect. Otherwise, maybe afterwards I thought I should have used Scala, because it's statically typed, and I can use Eclipse to generate code inside for my, and autocomplete for my solution. Right now, it doesn't do that. I had 2 minutes? 3. I had a little quoting hell. So you have identifiers, and if you pass them around, Clojure is going to compile them, and it's going to think there are variable references, you don't quote them, and it's going to throw an error, and you have to pay very nice attention to your quotes. And they have colon keywords, which evaluate themselves in Clojure, and I should have used those, but I don't like it how they look, so I didn't, and I have pain. And Clojure is mostly functional, so it's not a great fit for a GUI, which is mostly a state that gets modified a little. So I had to work around that. There's also a Clojure be ugly. This is kind of ugly. This is what happens if you make a mistake in your macro somewhere and you get a totally unreadable, unusable stack trace in the parser or in the compiler, and you know, go figure out what went wrong. And that's horrible. And actually, I lied a little, because when I said there is no IDE support and I don't have live warnings, that was true yesterday when I wrote this presentation. It's not. It was true until tomorrow. This morning, it was true until this morning, because this morning I made an editor. See, on the left, I have my same program. I can type. And for example, when I change this value, you see the thing, at the top you see it changing immediately. And also to the right, I have a nice field where arrows appear. Should I make an error? See, I can also change the structure. I want to put the field below inside inside the group. It's okay now. For example, let's say I reference a value that doesn't exist, value residue blah. It will tell me, hey, there is an unrecognized reference there. So this is already starting to look like something that you can put in front of a user. Right? You type, you see the results, you get an error on what went wrong. I don't have, underlines here. But I do have some live feedback, live error reporting. And this was 20 minutes and 30 lines of code to make this morning. And it can only get better from here. So I would say, Clojure, it's not a language workbench, but it gets most of the stuff you can make, that you need, you can make very quickly, very easily. And it's efficient, and it's also fun. Thank you.